Hello guys, welcome back to my YouTube channel. Are you preparing for a SQL interview and struggling to know which questions to practice? Don't worry. In today's video, we are going to solve 20 important SQL interview questions in just 20 minutes. And we are not just going to look at the answers. I'll explain what each question means, how to approach it, and what SQL code is doing. So, whether you are a beginner or preparing for your next interview, stay till the end and practice along with me. Grab your notes and let's start solving. Our first question is combine two tables. Here we have two tables, person and address. The person table contains first name and last name, and the address table contains their city and state. We need to display the person's name along with their address. Even if a person does not have an address, that person should still appear in our result. So in this case, which join should we use? We need a left join. So let's see the query. Let's understand this step by step. Here, select tells SQL which columns we want to see. P dot first name and P dot second name come from the person's table, and A dot city and A dot state comes from the address table. Here P and A are just aliases. Then we have person P, which is our main table. We need to use a left join address A. A left join means keep every record from the left table even if there is not matching a record in the right table. And this line P dot person ID equal to A dot person ID tells SQL how person and address are connected. So if a person has an address, we get their city and state. If they don't, city and state will simply be null, as you can see here. Whenever the question says, give me all the records from the table, even if there is no matching record, then we need to use a left join. In this, we need to find employees earning more than their managers. At first, this might look confusing because we have only one employee table. But both employees and managers are stored inside the table. So we need to compare one employee with another employee from the same table. In this concept is called self-join. So let's move to the query. In this query, we need to use the employee table twice. E represents the employee and M represents the manager. Then E dot manager ID equal to M dot ID. Once they are connected, we compare E dot salary greater than M dot salary. In simple words, is the employee's salary greater than their manager's salary? If yes, we return the employee. Remember, same table plus comparing different rows equal to self-join. Now let's move to the third question. In this question, we have duplicate emails. The question is asking us to find email addresses that appear more than once. As you can see here, this email address is appearing twice. So let's think about it. If the same email appears multiple times, we need to put those emails into groups and count them. So let's move to the query. First, we need to group by email. Then, which puts identical email addresses into the same group. Then we need to count how many times each email appears. So count greater than 1. Notice we are using having, not where. That's because we are filtering groups after aggregation. A very useful interview rule is where filter rows having filter group. So the fourth question is customers who never order. Now let's find customers who never placed an order. We have a customers table and an orders table. We want all the customers who don't have a matching order. This is another perfect example of a left join. We start with customers because we want to keep every customer. Then we left join orders. If a customer has an order, the order information will be available. But if they don't have an order, the order columns will be null. That's why we use o.id is null. Basically, it says show me customers who don't have a matching order. Remember, left to join plus is null is a very common pattern for finding records that don't have a match. Now let's move to the fifth question. Here we have big countries. A country is considered big if the area is at least 3 million or population of at least 25 million. The important word here is or. The first condition checks area greater than or equal to 3 million. The second checks population greater than or equal to 25 million. And because either condition can make a country qualify, we use or. For example, if a country has a smaller area, it can still qualify its population of at least 25 million. So always pay attention to whether the question says is or and. Now let's move to the sixth question. Here we need to find the department highest salary. We need to find the employee or employees with highest salary in each department. If the employees have the same highest salary, both should be returned. So we need to find the maximum salary separately for each department, each and every department. Let's start with a subquery. Group by department ID. Creates a separate group for every department. Then max salary. Finds the highest salary inside each group. So this subquery gives something like department 1 equal to 1 lakh, department 2 equal to some around rough amount. Now the outer query looks at each employee and checks whether their department and salary match of these maximum values. We also join the department table because we want to display the department name and because we are matching the maximum salary rather than selecting only one row. If two employees share the highest salary, both can appear. Here, you need to remember group by plus max plus subquery is an important interview question. Now, let's move to the seventh question. In this seventh question, this is most of the like common SQL interview questions. For every interview, this SQL question is mandatory. Second highest salary. The easiest way to think is find the highest salary. Then the second highest will be found out. Let's start with the inner query to find the highest salary. Then if suppose if the salaries are 100, 200 and 300. So if they say to find second highest salary, then our second highest salary will be 200. First, our inner query will give 300. So after finding the highest salary, which is 300, the 300 will be removed. So we need to take the maximum value between these two. So the logic is simple. Find maximum, then exclude it. Then find the maximum again. Now let's move to the next scale question. Here, nth highest salary. Now we are extending the previous question. Instead of finding only the second highest salary, we want the nth highest salary. First, here we need to declare m int. which creates a variable called m. Then, why do we subtract 1? Because offset starts from 0. For example, if we want the second highest salary, we need to skip the first highest salary. Next, select distinct, which makes sure duplicate salaries don't interfere with our ranking. Then, order by salary from highest to lowest. And finally, limit 1 offset m. Skips the salaries we don't need and returns one salary. So the important concepts are here are distinct, order by, limit, offset, and functions. Now let's move to the ninth question. Here, let's talk about ranking. Suppose our scores are 4, 4, 4, 3.85, and 3.65. Two people with same 4 should be ranked 1 and the next score should get ranked 2. For this, we can use dense rank window function. Dense rank is responsible for assigning the rank. Instead, we have order by score by descending, which means the highest score comes first. So 4 gets rank 1, 3.85 gets rank 2, and 3.65 gets rank 3. The important thing about dense rank is that equal values receive same rank and there are no gaps after a tie. This is a very important common window question, interview question. Now let's move to the 10th question. Classes with at least 5 students. Now we need to find classes that have at least 5 students. This is another classic group by I'm having question. First, we need to group by class, which creates one group for every class. Then we need to count the students in each class. Finally, having count student greater than or equal to 5 keeps only the classes with 5 or more students. Again, we are using having because we are filtering an aggregate result. So remember, group, count, having. Now let's move to the another question. 11th question. Customers placing largest number of orders. Now we need to find a customer who placed the largest number of orders. Let's think about the steps. First, group by customers. Then count the orders. Then sort from highest to lowest. And finally, take the first result. So limit 1. Let's move to the 12th question. Another one important interview tip is this pattern is worth remembering because it appears in many SQL interviews. The pattern is first group them, then count, then sort, then take the top result. 12th question is department top 3 salaries. This one is a little more advanced question. We need the employees whose salary falls within the top 3 unique salaries in each department. The words in each department are very important here. First, we need to create called rank salaries. It is basically a temporary result that we can use in a query that follows. Inside it, we use a dense rank to rank the salaries. Now look at the partition by e.department ID. This is very important. It tells don't rank everybody together. Start a separate ranking for each department. Then order by e.salary puts the highest salary first. Finally, outside this, rank greater than or equal to 3. Keeps only the ranks 1, 2, and 3.
The important pattern is this in this is dense rank and partition by. The next question is first login date. Here, let's move to the user activity question. We need the first login date for every player. If a player logged in multiple times, we only want the earliest login. Whenever you see words like first, earliest, oldest, minimum, here group by creates a group for every player and min event date finds the earliest date for the player. So the entire query basically says for every player, give me the minimum event date. The next question is the question builds on the previous one. It depends on the previous question. But now we don't just want the first login date. Here we want to know which device did the player use their first login. This makes the problem slightly more interesting. First, the subquery finds the earliest event date for every player. So now we know that player's first login date, but we still need the device. That's the outer query. Go back to the activity table, then look for the row where both player ID and event date match the values from the subquery. Once we found the exact row, we can return its device ID. So the important lesson is finding the minimum value is easy. Finding another column associated with the minimum value requires another step. The next question is now we are working with two tables sales, product. The sales table contains product ID, year, and price. The product table contains the product name. We start selecting the columns we need. The product name from product table and sales from the sales table, say year and price. So we need to join the two tables. The line s dot product id equal to p dot product id tells SQL how the tables are related. In simple terms, match each sale with the product that belongs to it. The interview concept here is understanding when information is spread across multiple tables, you need a join to bring it together. Now, another question. Now we want to calculate the total quantity sold for every product. Since the same product can appear multiple sale records, we need to combine those rows. First, we are grouped by product ID. We are using group by product ID, which puts all sales for the same product into one group. Then we are adding the quantities together. For example, imagine product 100 has two sales, 10 units and 12 units, then becomes 22. So the pattern here is very simple. Group by plus sum calculates total for each group. Now, another question. Now we are asked to find the best seller based on total sales. But there's an important detail. If the two sellers have the same highest sales, we need to report both of them. So here, first we need to create seller sales. Group by seller ID creates one group per seller. Then calculate their total sales using the sum. Here we have something like 2,800 and 800 and 2,800. Next, the outer query finds the maximum of total sales. Then we return every seller whose total sales equal to 2,800. Notice we don't use limit 1 because There could be a tie, and we want all sellers with highest total. The main concepts are group by, sum, and finding the maximum. The next question is not boring movies. Now, here we have a filtering question. We need the movies where the ID is odd, which, which have an odd number ID. And the second description is not boring. The first question to find an odd number is ID mod 2 equal to 1. So if a number divided by 2 leaves and remainder of 1, it's odd. Then description is not equal to boring. Removes the movies where the description is boring. And we use and because both conditions need to be true. Finally, order by rating. Sorts the movies from highest to lowest. The next question is now we are getting into one of the most advanced questions. We need to calculate total sales for each product for each year. The tricky part is that sales are given as the data range. For example, a product might have sales from January 25th to February 28th. So we need to generate each date in the range. The query uses recursive. Here, the first part starts with product starting date. Then union of them, then add the dates from the current date and the interval of day 1. Moves the date forward 1 day and make sure we stop when we reach the end date. Once we have all the daily dates, we use year of t dot current date to identify each date belongs to. Calculate the sum, then calculate the sum. Finally, we group everything by product and year. This question is testing several advanced concepts. Here we are using date functions, joins, group by, and sum. And finally, average selling price. The question is slightly different because we are calculating a weighted average. We have one table which tells the price of a product during a particular date range, and another table tells us how many units were sold on a particular date. First, we join the prices and units sold tables using product ID. Then, but we can't just match every price with every purchase. We need to make sure happened while the particular price was valid. That's why we have this line. Now let's understand the calculation. This part calculates the total revenue, and this part calculates the total number of units sold. So our formula is total revenue divided by total units equal to average selling price, because selling 100 units at one price should have more impact on the average than selling only 5 units at another price. Here, round off to rounds our result to decimal places.
Alright, guys, that's a wrap on our 20 SQL interview questions in 20 minutes. I hope you now understand the logic behind the queries, not just the code. If this helped you, like, subscribe, and follow Nishzzz Diaries. Keep learning, keep growing, and I will see you in the next video.